Let us consider the case na hindi na straight line yung ating path. What if, instead of a line, our path is now a curve? So, consider a ball acted by a constant force. So, constant pa din yung force natin. But this time, the displacement is no longer a straight line, but the ball moves with a curved trajectory. Okay, so paano natin solve yung work done by this force for case na hindi na straight yung path? Now, so far, what we know is the work done if straight line yung ating path. If this is our force, tapos this is our displacement S, then the work done by this force is F dot S. Now, since alam natin yung work done, if straight yung displacement, one strategy that we can do here is to approximate yung ating path as a straight line path. So, what we can do is, sabihin natin, approximately ganito yung displacement niya. But of course, ang makukuha nating work done has a very large error kasi hindi naman talaga siya exactly the same. So, in order to increase yung accuracy ng work done na na-solve natin, another thing that we could do is to divide yung ating path into different sections. So, let's say, okay, so we still got the same force, pero this time, let's divide it into 4 equal parts. Okay, so subdivided na natin yung path. Now, let us solve for the work done by this force for each of the segments na slice natin. So again, para alam natin paano siya i-solve, we will approximate yung displacement with a straight line. So for this first part, ang displacement niya is ganito. So we will call this displacement, since segment lang naman siya nung original natin na displacement, we will call this ds. Okay? So that is the first ds. And then yung next, approximate natin a straight line, and so on. And since ang force natin is constant, at this point here, ito din yung force applied. Likewise, ganun din yung force dito. And ganun din dito. So, what we are going to do is to solve for the work done dito muna sa first segment, tapos dito sa second segment, tapos dito, tapos dito. Tapos i-add up natin lahat yon to solve for the work done by this force throughout the path. Now, of course, hindi pa din ganun ka-accurate yung makukuha nating work done kasi hindi pa siya exactly the same. Now, another thing that we could do is to increase yung number ng divisions natin. So, this time, let's try doing 8 divisions. Tapos, we will do the same. We will approximate each segment with a straight line. Tapos, let's call that displacement ds. And then, our force is constant again for each of these path. So, constant yung F for each of the segments. Tapos, we will solve for the work done for each segment. Work done ng force na ito. Tapos, we will add them all up. Now, again, since hindi talaga siya exactly the same path, hindi pa rin accurate yung makukuha natin na work done. However, if we look at our 3 examples, nung first na approximation natin, sobrang layo talaga dun sa original path. Now, when we subdivided that original path into 4, we've seen na medyo mas malapit na siya, pero hindi pa rin siya ganun ka-accurate. When we increase the number of divisions, we see na papalapit na tayo doon sa original na path. So, may nakalimutan tayo dito, may isa pa. So, mas malapit na tayo doon sa original path. Now, what if we increase yung number ng divisions to infinity, thereby yung ating ds, yung length ng ating ds will now approach to 0. Sobrang liit na niya. So in that case, we will see na our displacements, ds, will now follow yung original path. And we expect na if we do that same process for very small ds, then makukuha natin yung accurate na work done. So what we are actually going to do to solve this is to subdivide ang ating path into many small infinitesimal paths and solve for the work done. So basically, what will happen is we will add all the segments of the work done by the force for each of our ds segments as ang ds natin will approach to 0. Now, this expression here is actually the definition of an integral. So, our work done is the integral of f dot ds. So, for a curved path, hindi na natin kayang gawin yung normal lang na dot product. We will have to use calculus in order to solve for the work done in a curved path. So basically, this integral here means that we are subdividing our path into very small ds, and adding up yung work done ng force for each of those very small displacements. Now, what if your force is no longer constant? Isang example nito is the force exerted by a spring. Let's consider this case here. While this spring is compressed, so it exerts a specific amount of force. Let's call this force elastic. Pero, as the spring expands, thereby moving yung ating object, the force of our spring actually decreases. So, dito konti na lang. So, for this case, the displacement is a straight line. So, what should be the work done for this case here? Now, we've already showed yung ating integral for work done. That is f dot ds. But since our force is changing, depende sa length ng displacement. So, kung zero yung displacement natin, for this case, malakas yung ating force. Pero kung mas malaki yung amount ng displacement, lumiit yung ating force. So, we can say that our force, elastic, is dependent sa ating displacement s. So, pakita lang natin siya sa equation by making your force F as a function of S. And interestingly, this is also the general equation for work done. So, for any other case na pwede nating i-imagine, we can use this integral equation here to solve for that. Kaya siya tinawag na general equation kasi it works in any situation na pwede tayong mag-solve ng work done. We can also solve for what we call the total work done. So this is on an object. So the total work done is the sum of the work done by all the forces acting on an object. So suppose you have multiple forces acting on a single object. Say you have F1, F2, F3, and so on. Then the total work done on your object is simply the sum of the work done by each of the forces. So you solve for the work done by force 1, add to that the work done by force 2, add to that the work done by force 3, and so on. So add lang natin yung work done ng lahat ng forces that is acting on the object. Or what we can do here is expand yung equation for the work done. Itong equation na ito. So, we can write this as. So, work done by force 1. Ang equation natin for that is F1 dot S. Assuming na hindi changing yung force at hindi curved yung path. So, that is work 1. Work 2 is F2 dot S. Work 3 is F3 dot S, and so on. So what we can do here, since pare-pareho lang naman yung value ng S because we are talking about the same object, we can factor out ngayon yung pag-dot sa vector S. So we are left with F1 plus F2 plus F3, and so on. Dot sa vector S. Or, this expression inside, this is simply your net force. So, we can write yung expression for total work done as the net force dot S. So, this is another equation that you can use to solve for the total work done on an object.